This video is going to cover examples having to do with perimeter, circumference, and area, and we're going to try to answer the essential question, how are perimeter, circumference, and area calculated? First example here, find the perimeter and area of the rectangular basketball court shown. Well, the long side of the rectangular basketball court is 84 feet here. The shorter side is 50 feet, so if we start with perimeter, we're going to multiply 2 times 84 plus 2 times 50. That's the same as adding all the side length. This is going to be 84 feet here, and this will be 50 feet here as well. When we do that, we end up with 268 feet perimeter around the basketball court. And what's the area of the basketball court? That's going to be our 84 times 50. Which is 4,200 feet squared, or squared feet. Okay, here's another rectangle. Find the perimeter and area of the dining room. Again, our perimeter is going to be twice the longer side 12 plus twice the shorter side 9. That's 42 feet. And its area will be the product 12 times 9, which is 108 square feet. Okay, here's a circular patch, and you want to find the approximate circumference and area of the patch shown. In order to find circumference and area, it will be important to figure out the radius. Now this 9, we can redraw that 9 centimeters here through the middle of the patch. We can see that that's the diameter, 9 centimeters, which tells us the radius is going to be 4.5 centimeters. So the circumference is going to be pi times d, which is pi times 9. And that is approximately 28.27 centimeters. And the area of the patch, pi r squared, is going to be pi. Now the r is the 4.5, so we're going to multiply pi times 4.5 squared, and that is approximately 63.62 square centimeters. Again, here find the approximate circumference and area of the circular window shown, and we're told that the diameter is 18 inches. So this diameter here is 18 inches. That tells me that the radius is half of that, which is 9 inches. So the circumference, which is pi d, it's also 2 pi r. So we can rewrite that 2 pi times 9. That is approximately 56.55 inches. And the area of the circular window, pi r squared, which is going to be pi times 9 squared, is approximately 254.47 inches squared. Find the area and perimeter of the figure, if necessary, round to the nearest tenth. In this figure, all 4 sides are shown to be congruent, and one side is 1.6 centimeters. So if we start out with the area of this figure, Since the sides are congruent, we know that this side is also 1.6 centimeters, so the area is 1.6 times 1.6, which is equal to that area is equal to 2.6 centimeters squared, rounded to the nearest tenth, and the perimeter is all four side lengths are the same, so 4 times 1.6, which is equal to 6.4 centimeters. 6.4 centimeters. Triangle QRS has vertices in the coordinate plane, Q at point 1, 2, R at the point 4, 6, and S at the point 5, 2. What is the approximate perimeter of triangle QRS? Well, in order to find the perimeter, we actually need to find the length of the sides. That's going to require our distance formula. So if we look for the length of the side QR, we're going to need to apply the distance formula and take the square root of the difference in the x-coordinates, 4 minus 1 squared, plus the difference in their y-coordinates, 6 minus 2 squared. That's going to get us the square root of 9 plus 16, which is the square root of 25, which equals 5. So QR has a distance of 5. Another side length, RS, we'll figure out RS down here. RS is going to be the square root of 5 minus 4 squared. That's the difference in the x-coordinates, and 2 minus 6 squared is the difference in the y-coordinates. So RS is the square root of 1 plus 16. That is approximately 4.1, just a little bit bigger than 4. And we did QR, we did RS, we need this side SQ, and that will be the last side length in order to find the perimeter. SQ will be the difference in their x-coordinates, 5 minus 1 squared. The difference in the y-coordinates, 2 minus 2 squared. SQ is going to be the square root of 16, which is equal to 4. So our final answer, our perimeter, P, is going to be 5 plus 4.1 plus 4, and that will be 13.1. Okay, use the diagram below to answer A and B. Part A is describe how to find the height from F to EG in the triangle below. The height from F to EG is the line that is line segment from F to EG so that it's perpendicular to EG. Well, if we follow the grid line there, don't want to do that. If we follow that grid line there, the grid lines are perpendicular, and since F will intersect, well, let me draw that again, right on the grid line if I can. F will intersect EG right at this point right here, which has coordinates 1, 3. We know it's perpendicular because of the grid lines, so for part A, we can find the height by finding the distance between, if we call this point H here, we can find the distance of FH. So that's going to be 7 minus 1 squared plus the difference in the y-coordinates, 3 minus 3 squared. And that's going to be the square root of 36, which equals 6. So we can find the height there. That 6 should also be just counting the grid lines. 1, 2, 3, 4, 5, 6 from H to F. B, find the perimeter and the area of the triangle shown below. If I clear the screen here, the perimeter, as we saw in the last example, is going to be the distance around this figure. We'll have to figure out the distance from the vertices. So the distance EF is going to be 7 minus 1 squared plus 3 minus 6 squared. Those minus signs aren't showing up. There we go. It's a little better. And that's going to be the square root of 36 plus 9, which is the square root of 45, which is roughly 6.7. EG, this side length is going to be very easy. We can simply count the grid lines, and we know that this has a length of 4. 1, 2, 3, 4. FG, we'll use the distance formula, and we'll take the difference in the y-coordinates, the difference in the x-coordinates, 1 minus 7 squared plus 2 minus 3 squared, to get us the square root of 36 plus 1. So that's the square root of 37, which is roughly 6.1. So the perimeter of this triangle is 4 plus 6.7 plus 6.1, which is 16.8. Okay, now for the area of the triangle, we know that the area is 1/2 the base times the height. We can call EG our base. That base is EG, and we already know that its length is 4. The height we figured out in part A of this question, which is this distance here, which we calculated to be 6. So now it's just a matter of plugging in 1/2 times 4 times 6, and that gets us our answer 12. The base of a triangle is 28 meters. Its area is 308 square meters. Find the height of the triangle. Well, we're going to again use the formula for the area of a triangle, 1/2 the base times the height. We know the area is 308 square meters. We know that the base is 28. What we don't know is the height. So 308 equals 14h. Dividing both sides by 14 gets a height of 22 meters. If the base of the triangle is 14 centimeters and the area is 42, find the height. So 42, again, is 1/2 the base times the height. So 42 is 7h. That tells us that the height is 6 centimeters. An ice resurfacing machine is used to smooth the surface of the ice at a skating rink. The machine can resurface about 270 square yards of ice in 1 minute. About how many minutes does it take the machine to resurface a rectangular skating rink that is 200 feet long and 90 feet wide. Those dimensions are going to tell us the area of the rink, 200 feet long, times 90 feet wide. It's going to get us 18,000 square feet. If this ice resurfacing machine can resurface 270 square yards of ice in 1 minute, what about the 18,000 square feet? This is a tricky question because 1 square yard, 1 square yard is actually equal to 9 square feet. A yard is 3 feet, so 1 yard by 1 yard is the same as 3 feet by 3 feet, which is 9 square feet. So 18,000 square feet is the equivalent of 2,000 square yards. And if this machine can resurface 270 of those in 1 minute, then 2,000 square yards divided by 270 gives us our answer of about 7.4 minutes.